from the very beginning, let's go back to August and bring up something that I told you way back then. The purpose of a graph is to provide you with information about something that's happening in the real world. That's what it's supposed to do. It's supposed to give you some information, and you're supposed to be able to glean from it some conjecture. So I want to remind you or show you a graph that we had way back at the beginning of the year, probably the first kind of graph I presented to you when we were first learning the vocabulary of physics. It looked just like this, and it said position versus time. Units were given, most likely, and I think this was labeled A and B, and somewhere around here was a time, like say 5 seconds. Now, every graph that you are that you will be presented is attempting to tell you something. You should, when presented with the graph, ask yourself what is being displayed. You could turn this into a simple fill in the blank. Something like this is comparing blank with blank. But it's probably better if you come up with a sentence that describes what is being demonstrated. Do that before you read the question. You're going to be given graphs on the exam, and you've been given graphs in your multiple choice, and a lot of times you just kind of blow through it. And if you're like anything like first period, you'll say things without thinking them through. For example, is there ever a time on this graph when the two objects have the same speed? I can just look real quick and I see a few things like this. But you don't know what this graph is displaying if you said yes. And it's because of that I think you guys have problems. You jump at things. And they're intentionally going to try and trick you. Now, it's not intentional, I guess is the wrong word. They're going to try and put things in front of you that they know you guys will answer incorrectly because you're not thoughtful about what's being displayed. So, let's try and be thoughtful about what's being displayed. And let's go one step further and also add to it, what other information does the graph have that is being communicated to you that might not be just what the graph is displaying? So right now, consider these things. What is the graph displaying? Consider the meaning of the slope and the meaning of the area. If you don't remember how to do those things, what is being displayed is a sentence that describes specifically the display of the graph. Something about the vertical axis and the horizontal axis, something's being communicated. To deal with the slope, you just take what's on the vertical axis and divide by what's on the horizontal axis, and also do the same thing with the units. For area, again, you take what's on the vertical axis and multiply by what's on the horizontal axis, and do the same thing with the units. Your goal is to see if the units or the slope or area, if it kind of communicates some other meaning. You said the slope is the velocity and the area is the displacement. One of those two things is true. So when we look at the slope and the area, we do take a look at the units and see if the units match up with something that we already know about. Meters per second, definitely velocity. Meters times second, not displacement. Displacement would just be in meters. So I don't know that the area of this graph has any meaning because I don't know of anything in our equation sheet or in our units system that's meters times seconds. So I think I'm going to throw away the area as not being useful, but I do think the slope is the velocity. So we'll start with that. We tested the slope and we tested the area. We have some information we can walk with. I think we're going to say the slope is the velocity. But what you didn't actually answer was, what is this actually displaying? Can somebody offer me a one-sentence explanation of what's being displayed? Go ahead. Should have said a name. That's okay. Go ahead, David, louder. Let's see what you said. I think that's okay. I'm looking for simpler words, though. Something that you could communicate to a child. Yeah. That's more information than we need. This graph Just what does it show? Simple. Go ahead.
How far an object travels over a certain period of time.
So all of these things are things that you are interpreting from the graph. You're making assessments of the graph. The graph just tells you where the object is at any moment in time. Right? It says where. Position is where. And any moment in time. Now, you've made several assessments because of that. You've talked about change in the position. Well, I could have a graph of an object that's position versus time that shows it doesn't change, right? I mean, if I just drew this in, object C. Let me make sure. There, object C. Does object C change its position ever? No, but this is still a graph that tells me where object C is for every moment in time. It also tells me where object A is and where object B is. It's a position versus time graph. It shows you where something is. I want an overview. Now, yeah, you could start to tell me more information. A position versus time graph could tell you other things, like it's traveling away from something or towards something. You could get that from a graph, but that's starting to interpret the actual data points. That's more than just what does the graph display. A lot of times you don't stop and ask yourself, what is the graph showing? You jump into trying interpreting it, which is why several of you got the question wrong. When does the object have the same speed? These objects never have the same speed. Not once. Something is happening at 5 seconds, but they don't have the same speed at 5 seconds. But you jump at those kinds of questions because they feel like they're just easy. And it's obviously something's happening there. But do they ever have the same slope? If the lines never have the same slope, they never have the same speed. Go ahead.
So like one of the my questions, there was something where it was asking about where it would have the same velocity as each other, and it was kind of like a straight linear line, and then one that was kind of curving like that.
Yep, we're going to take a look at one of those. That's our second example.
Okay. Is that just to find that would be slope as well? Because I was confused how because I didn't even pick what the right answer was. My problem.
All right, well, let's make it through this one, and then we'll do one like what you're describing. Is that good for you? All right, so A and B never have the same slope, so they never have the same speed. Something is happening at 5 seconds, and I hope you know what that is. But it looks like A started behind B. Would you agree with that? I'm looking at time 0. A started behind B. B doesn't travel as far in the 5 seconds as A does. Can you all see that okay? So that's another thing to consider. A is traveling faster, so it travels farther in 5 seconds than B does. But A is passing B at 5 seconds. But is there ever a time in this graph that A and B have the same speed? No. So let's talk about your question, because I think your question is well timed for what we want to do next. So I'm going to change it just a little bit. Let's put one of the cyclists back up there. Cyclist A, and then cyclist B. Okay? This gives us some place to start. We'll say that this is 2 seconds, and this is 10 seconds. Now, what is being displayed? Same as before. Where the object is at every moment in time. But there's also other things we could get from this information, can't we? Does cyclist A and cyclist B ever have the same speed? Now, does cyclist A speed ever change? No. Does cyclist B speed ever change? Yes. Is cyclist B speed increasing or decreasing? Increasing. The slope is becoming steeper. Correct? In fact, if I was to take a look at the slope, I think cyclist B starts with a slope that's almost 0. So maybe cyclist B, when we start observing, started from rest and wasn't moving at all, and then saw cyclist A coming at him and started to speed up. Would you agree with that? A reasonable assessment? And then, is there ever a time, I'm trying to make these two lines parallel. Is there ever a time when the slope over here is the same as the slope over there? Yeah, I think so. In fact, I'm arguing that right about where I have that red line is probably where cyclist B and cyclist A have the same speed. You guys agree with that? It's only for an instant, isn't it? Because cyclist B is speeding up all the time. Cyclist A has the same speed all the time, but it looks like to me, somewhere between 2 and 10 seconds, cyclist B finally has the same speed as cyclist A. Cyclist A is ahead of him though, right? You can see that too, because it looks like they have the same speed right here. Would you kind of agree with that, where I put it? At that moment, though, cyclist A is further away. It's further ahead, farther away from the origin. Will cyclist B ever catch up to cyclist A? Yeah. Do they have the same speed when cyclist B catches up to cyclist A? No. At that point, who's going faster, B or A? B. Does that answer kind of the question that you had? Now, the truth is, I could have kind of crazy cyclist C. I think cyclist C, I don't know what he's doing. But would you agree that cyclist C probably has the same speed as cyclist A a couple of times? Any place where the graph would be the same slope as cyclist A. So maybe over there, and maybe right here, and maybe right there, maybe right here. But there's times when he's speeding up and times when he's slowing down. He's very erratic. Would you agree? He's all over the place. So cyclist C is kind of crazy, but he has the same slope as cyclist A several times. All good so far? Position versus time graph tells you where the object is for every moment in time. You can get from it a reasonable understanding of how their speed changed or stayed the same. So the slope of a position versus time graph is velocity. The area of a position versus time graph has no meaning. So, moving right along, because we did that for like a week, and then it was time for us to put on our big person pants and hit the real graphs, stuff that had more information. So, I don't know that you will remember these, but okay. This is a velocity versus time graph. Talked about it at length. Take a moment and assess what is being displayed. Maybe ask yourself what is not being displayed. And meaning of the slope, meaning of the area. So, we want to offer what is this graph showing us? Go ahead, Camilla.
No. It's showing the velocity of something as the time.
Right, it's showing us how fast something is going for every moment in time. But it tells us more than just how fast something is going. What else does it tell us besides how fast something is going? No, just what it's showing us, not interpreting. It gives us more than just how fast. It gives us direction. It tells us whether it's going forwards or backwards. So it tells us how fast and in what direction an object is going for every moment in time. All right, can somebody tell me what the meaning of the slope is? Lance?
Would the slope be acceleration?
The slope is acceleration. Can somebody tell me what the meaning of the area is? Go ahead. Displacement. So this graph shows us the speed and direction of the object, but we can interpret from the graph the acceleration of the object and the displacement of the object. Is there anything that this graph can't tell us? There's some things that this graph can't tell us. I'm not sure if you remember what it is. Does this graph ever tell us where the object is? can't tell us where the object is. It can tell us how much the object moved, but it doesn't know where it started. So one thing that's left off, because it's not a position graph. So although we can find out information, there's information that is missing. So, is this object ever stopped? So Corbin, when is it stopped? 5 seconds. So let's ask some more difficult questions. All right? Is the acceleration ever positive? So I have more confusion here because people are doing this or this. Is the slope ever positive? No. So the acceleration is never positive. In fact, we could argue right now, is the slope ever changing? No. So this object has a constant negative acceleration. Is the object ever slowing down? It has a constant negative acceleration, but is the object ever slowing down? See what I mean when I say you guys have a hard time with this stuff? But if we look closely at this graph, its velocity starts at some positive number here. I picked 1 point because the graph tells us how fast and in what direction the object is going. So right now, it's going something positive right there. Is the object's speed faster or slower at point 2 compared with point 1? Slower. So did it speed up or slow down between point 1 and point 2? Slowed down. In fact, at point 3, what's its velocity? 0. So I think we could say pretty clearly that it's slowing down. Is it still slowing down at point 4? Whoa. What do you mean? The acceleration is negative. But doesn't that mean slowing down? No, acceleration doesn't tell you slowing down or speeding up. It tells you how the velocity changed. The velocity is becoming a more negative number. It started at a positive number, but the velocity is becoming a more negative number. Once I reached a velocity of 0, the velocity became a more negative number, so now I have a negative velocity. It just means it's going backwards. And in fact, at 5, is it going faster or slower than it was at 4? Faster. Is it going forwards or backwards? So a negative acceleration doesn't mean slowing down or speeding up. Slowing down, speeding up is conditional. You have to look at the conditions. This graph told you. It tells you everything about that. In fact, it tells us more than that because, as you said, this area, an area is the part between the curve and the horizontal axis, assuming the horizontal axis is a 0. Is that area positive or negative? Positive. So it traveled in the positive direction. And this area, is it positive or negative? So this has to be a negative displacement. So, with all that wonderful talk, and you guys knowing all these wonderful things, and you're quite capable people, assuming at t equals 0, x equals 0. Plot x and t. Can you make the position versus time graph? Let's say that this is 5 seconds. What would it look like? Where is the object at every moment in time? A position graph can tell you velocity, correct? We just talked about it. How do you determine the velocity from a position versus time graph? Slope. Okay. So at the point marked 1 on the velocity graph, is the velocity positive or negative? Positive. Is it a big number or a small number? Compared to everything else, it's a big positive number. So at 0 on your position graph, the slope should be a big positive number. right? Position of slope. All right. Is the velocity ever 0? Yes. When? 5 seconds. Okay. So at 5 seconds, the slope of your graph has to be 0. Has to be, right? Going from time equals 0 to 5 seconds, was there a displacement? Yes, right? There's a positive area. So I had a positive displacement, which means I am somewhere in front of where I started. And at that moment, I have a slope of 0. Aren't these are all just reasonable deductions, right? You guys tend to want to just jump at it, but you don't have to. Just ask yourself some reasonable questions. After 5 seconds, is my slope going to be positive or negative? Negative. In fact, it looks like it's going to mirror the same thing that just happened to get to where I was. So probably over, say, here, am I going to have a positive or a negative slope? Negative. I know I'm going to be coming back because I know I have a negative displacement, right? Because I have this patch of area that's negative. So I'm expecting a slope that's like that. Can you connect this with some kind of smooth curve? I don't know that you're going to have to do this on your exam, but whenever you guys have had to make a graph on your exam, you guys tend to try and jump at it. You know, like they've given you information to use. Use it. What's being pictured? If it's picturing where the object is, then what was the object doing while it was moving? It was slowing down and speeding up. Put those things in there. All has meaning. Now, we have limited time to do all this, but obviously we could do other examples of this. I've given you one, but I want to talk about other graphs now that we've had less experience working on. Because the position versus time graphs, go back to your homework. You had lots of it. How about this one? This one's going to show you a lot more than you probably realize, which is why I want to get to it. This graph, it's amazing what you can be given with this graph. So, did you come up with a description? What are we displaying here? This is the force on an object over some time interval. This is how much pushing was done to something over some time interval. Was the force a constant? Yes. No, the force was changing. The force started at 0 and went up to 10 newtons. That's important because that tells you so many things. So many things are just in that one idea, because net force equals ma. Was the acceleration constant? Yes. Nope. No. If the force wasn't constant, then the acceleration wasn't constant. So no, there's not a constant acceleration. That means stuff. Not constant acceleration means no motion equations can be used. All of your motion equations assumed a constant acceleration. This one can't do it. Did you test slope and area? Slope is force over time, newtons divided by seconds. Area is force times time, or newtons times seconds. Do either of these have meaning? Yes, one does. Which one? What is it? That's right. This is impulse. Impulse is change in momentum. The area of this graph has meaning. Slope doesn't. Area does. things this graph can't tell you. Can't tell you where the object is. Doesn't contain it, doesn't have it. Can't tell you how fast the object is traveling. And actually can't tell you the acceleration unless you have the mass. But if you were told that it started from rest, you could figure out what the object's velocity is after 2 seconds because you have the change in momentum. You could also figure out things like kinetic energy because you would have mass and you would have velocity. We'll pick this up tomorrow right here.